All right, good morning, guys. I've just started recording, so the people who join us a bit late, they'll just watch the recording for the earlier bit later on, okay? I think the first word I want to go through is this word on energetics. Okay, so I'm just going to use example of us now we work, but all of you already returned the script, already returned your work, so you should have access to your own mark script. And I will upload the PDF of my work solutions on my blog site a little bit, and the work tutorial has been released on the chemical energetics playlist if you want to go through the explanations verbally and stuff. Okay, so all of those resources have always been available to you from the very beginning. It's up to you what you do with it. But yeah, I mean, you have me to ask directly as well if you want to. Actually, it's not a very good idea to use Ask Now We Want. Not because his work is not good, but because he is missing the first page. I think I'm just gonna go for, I remember someone has the first page. I think Ang has the first page, okay? So in the first page, you have this combustion. What is very important is this is combustion. Combustion is always exothermic. Whenever you combust something, you burn in oxygen and it will always release heat, okay? We are burning alcohol here. We know alcohols are flammable, so it will catch on fire. So you need to be careful and keep alcohol away from fire. We burn it. This is called a wick. So it's like part of a candle. You know, you need a wick, okay? And then you light a fire on there, and it's gonna burn the fuel. As it burns, the alcohol will get consumed, the alcohol will get used up. If I just show you one particular alcohol, this is what you call methanol. This is straight from your year 9 name of covalent compounds. And you're expected to draw the dot and cross. For that, as you know, carbon form 4 bond. I think the whole class knows that, except for Hazwan, who had somehow drawn a carbon with 3 bond, somehow, okay? Anyway, so methanol burns in oxygen and you get carbon dioxide. So complete combustion will give you carbon dioxide, CO2, and you get water. Balancing our equations, we got 3 hydrogen and 1 hydrogen. So we have 4 hydrogens, we need 2 H2O there. And you got 2 oxygen and 2 oxygen, but 4 oxygen does not mean 2 there because you must keep your eye out on balancing equation. There is 1 oxygen there. You can have 3/2 because 3/2 times 2 is 3 oxygen atom. I cannot change the identity of the molecule, which is diatomic. Another thing you did in year 9 was to do the dot and cross of oxygen molecule. There were around 9 or 10 simple covalent molecules, all of which you're expected to know from the syllabus minimum requirement. Now the combustion of these will use up the alcohol and the mass of the alcohol will decrease. And that is why in this experiment, at the beginning, you have this much mass. At the end, the mass has decreased. I think everyone managed to get this correct, except for one person who had a negative mass because this person thought it's this minus that. But in reality, how much alcohol has been burned, how much alcohol has been used up has to be the one at the start, which you contain the alcohol inside the container, minus however much alcohol remains at the end inside the same container, you're gonna get 0.46. These are 2 decimal places, 2 decimal places. If this happened to be 0.4, doesn't make sense. Your calculator will not show you if it is 0.40. So you have to be able to write these to 2 decimal places based on the accuracy and precision of the data. Now, remember I told you in the class, in the lab last time, when you read your thermometer in the lab, your actual thermometer in the school laboratory is not a very accurate one. You only reach the nearest 0.5 degrees Celsius. You need to say they'll give you something 0.0 or something 0.5. However, these are the actual thermometer in this question. You will see that this is 25 and this is 26. In the school laboratory, the thermometer you have would have a 20 and 30. So each of these line will be 1 degree Celsius in the school. Here in this question, we have 25 and 26, which means you are reading upwards, which means that is 25.1, this is 25.0, and so on and so forth. So, this thermometer is actually fairly accurate, and therefore that reading there, you don't round it up, you read the actual value, that's 25.8 degrees Celsius. Same thing there, you read the actual value, that's 36.3 degrees Celsius there. Okay, I mean, I'm not surprised that some people thought that has to be 0.5 because they're thinking about if they're doing it in the actual lab. But have you read the questions? In terms of the questions, they can give you any sort of instruments. You have to be able to read data. This happened in physics, this happened in biology, this happened in chemistry as well. The rise in temperature, at least this one should have ECF. So you have gotten 1 mark for each of these and 1 mark for both of these. By right, Ang should have gotten 0 here. But anyway, he's got ECF based on the 1 decimal place. The rise in temperature also has to be 1 decimal place there. You haven't really done on these naming things, so I wouldn't blame you if you got this one wrong. But one of the most common mistakes is forgetting that there is a covalent bond there. People always forget there is a covalent bond there. People always forget there is a covalent bond. Oxygen formed 1 and 2 covalent bonds. Group 6 valence electrons, they want to form 2 covalent bonds. They want to share 2 electrons to complete the outer shell. This question is a bit weird because of this unit, which is actually wrong. Because relative molecular mass, the unit is not mole, the unit is gram per mole. Clearly, some people like Shakila and Hazika, Adriana, they really couldn't even do untitled chemistry, MR or AR. It's basically the mass for 1 mole of the substance. That's the definition, the mass for 1 mole of a substance. So it's the mass in gram over mole. 1 mole of this substance has this much mass, okay? Calculate the number of moles. Most people are okay, except for I think Nabila and a few other people does not understand that on the calculator, you have time 10 to the minus 3. Okay, I want everyone to just press the calculator again. You should be able to press 0.46 divided by 74. Your calculator displays 6.22, but times 10 to the minus 3 is on the far right of the calculator. It's like blah, 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 blah. And then here, there is times 10 to the minus 3. If you can't read these in science, you won't be able to read this in mathematics, and you have failed before you even started lower secondary mathematics. Everyone, almost everyone, I think about 5 or 6 people couldn't get this thing, okay? ECF mean error carried forward. So Ang here gets a mark because even though he used the wrong value, he had proceeded with the correct calculation. That's the meaning in calculation, error carried forward. You will get marked for the correct working because you already got penalized once. Now, people who lost the mark here would be those people who don't know how to key this into the calculator. Make sure you know how to key in times 10 to the minus 3, okay? Can people try and practice 6.22 times 10 to the minus 3 on your calculator? And can anyone shout out if you don't know how to key in times 10 to the minus 3? I assume everyone is okay then. So Nabila can't hear my voice and her mic is not working. So it's time to, so there's not much point for her then. That's the point. She can't hear my voice. Her mic is not working. So how can she go online lesson? Anyway, let me just reply her text. What is the point of online lesson if you can't hear the voice? If you can't speak on the mic? Don't know whatsoever. Okay, make sure you can key in this value into the calculator. There should be 6.22 once you key in. And I think if you press the button EXP on your calculator, that means times 10 to the power of, and then you press minus 3. So that is actually 6.22 times 10 to the minus 3. Okay, when you do something divided by 10 to the minus 3, you get something like 1,000 because 1 divided by 10 to the minus 3 is 1 times 10 to the 3. So people who got 1 times 10 to the minus 3 again, you don't know your basic mathematics, and I fear for your future in doing physics and maths and chemistry. Okay, not your first time already. Now this graph is about drawing a smooth curve. So make sure you know how to plot in the value. I did check. Okay, don't think I don't check. Okay, now I think it was Mumtaz who plotted for 0 carbon atoms, which is a bit strange because the table shows you 1 carbon atom, 2 carbon atom, 3 carbon atom. I think it was Mumtaz or someone else, I forgot, but someone else did plot it at 0 carbon instead of 1 carbon. Mistake number 1, plotting data, you lost 1 mark. Another thing is I check the point. I do actually check the point to make sure you can fill the data. I think I spotted 1 or 2 people who couldn't put the points correctly inside graph. This is a lower secondary mathematics graphing. You also have graphing definitely in physics. I am 100% certain graph will come up for your physics practical. Okay, I am 50% certain graph will come up for alternative to practical, but then actual chemistry practical, maybe not. Okay, depending on what kind of thing you have. Smooth curve. Do not put in the data. Do not draw a cross or a dot for the point where you don't have actual data. You don't have actual data for it. Do not put in the cross there. Use cross. Okay, there was 1 or 2 people, they try to use dot and stuff. Lukman has a very big cross that is not very good looking at all. Using your graph, sometimes they say show construction lines on the graph. Make sure you can use your ruler and show 3 carbons and then read the y-axis there. This is 0.6, this is 0.7. So make sure you know how to read it using your graph. Okay. Now this thing, you haven't really done this thing called isomer yet. This is actually year 11, organic chemistry. So what you have in the previous question was propant 1-ol. The 1-ol mean the OH is at carbon 1. So that means it's at carbon position 1. So that is just like that. So that is not the answer for this question. The answer for this question is actually the other isomer. So what I should have drawn for this question is not this. It should be, I moved the OH around. I moved the OH to carbon 2. So it's at position 2 now. It's in the middle. If you count the total number of carbon, it's still 3 carbon. So both of these, they have 3 carbons. They have 1, 2, 3, 4, 5, 6, 7, 8. They have 8 hydrogen and they have oxygen like that. This is called molecular formula. The definition of molecular formula is in your year 9 chemistry. And they can ask you, define molecular formula, because it's stated in the syllabus. Candidate should be able to state that molecular formula is the actual number of atoms in one single molecule, is the actual number of atoms. All right, so for this next one, this one here, this is an isomer of it. I've changed the OH from position 1 to position 2. I've got 3 carbon, I've got 3 hydrogen, 6 hydrogen, 7 and 8. So guess what? They have the exact same molecular formula, but actually they have different structural formula, and you will learn more about this in year 11 as the definition of isomer, molecules with the same molecular formula, but different structural formula. Now this thing, I have to go through this, okay? This is actually fair test. You want to have the same temperature rise for all experiment so that the result is fair, okay? Fair test is when you change only one thing at one time. Be very careful, yeah? Fair test means change one variable, change one thing at one time. So that means keep the other constant, keep everything else constant, keep all the other factors constant, okay? Accuracy. People talk about accurate. Accuracy has got to do with the procedures or the instrument. You haven't changed the instrument, you haven't changed the procedure. So how can it be more accurate? You cannot. Then some people say you repeat the experiment. Okay, when you repeat the experiment, you are talking about consistency, you're talking about reliability. Are you able to get the same result again and again? If you repeat it, that is called reliability or consistency. And then you do them, and then you average out the result to prove that your results are consistent and reliable like that. Okay, so be very careful. So in biology, I'm sure you already started talking about fair test in alternative to practical. Our next topic on rate of reaction, we will talk a lot about this fair test. So do not get confused between reliability, accuracy, as well as fair test. Now, this is the last question that was very badly done by almost everyone. Now, this is more of a physics question. I'm sure this will come out in your physics practical, almost more certainly than in physics and than in chemistry. This is to do with heating, okay? You want to talk about the apparatus. Someone hasn't muted themselves. Can you just check if you have muted yourself, please? Okay, so this one is obtaining more accurate results. Accuracy, okay, accuracy is to do with the apparatus. They say apparatus, improving the apparatus, okay? You are burning. There are actually more than one way you can improve this, okay? Let's talk about the physics, conservation of energy. Energy is being conserved. So that means you burned the ethanol. That is chemical change. So that is the chemical energy from burning the ethanol, the alcohol. And this is converted into heat energy. Why? Because we are heating up the water. We're heating up water. Heat capacity of water, the volume of water in cm cube, which is the same as the mass of water in cm cube, because you know in physics they will ask you this 1.0 gram per cm cube. So if you have 240 cm cube, so that means you also have 240 gram, because the density of water, 1 gram of water for 1 cm cube of water. So 240 cm cube of water is 240 gram. You have the heat capacity of water, which is 4.2 joule per Kelvin or joule per degree Celsius per gram or per cm cube. Heat capacity definition in physics. You have the change in temperature, Ti, Tf. This is equal to the change in temperature. Now we know that this energy from here gets converted into here. We assume 100%. We assume 100% conservation of energy. This is where your assumption gets broken down. Okay, where is the error? The error is in heat loss. Okay, you have to be aware that in this kind of experiment, they always come out. Yeah, they always come out, whether in physics or whether in chemistry, they always come out. Where's the error? The error comes from heat loss. If you say the error comes from equipment, yes, that's why you can improve the accuracy by using better instrument. Those are called systematic errors, and you have done those errors in physics as well under precision. Okay, I'm talking about the experimental procedure here, the setup. We don't change the apparatus here, but you can use a better thermometer. The most common mistake is, I don't know why, but a lot of people say change the metal can to beaker. If you change metal can to beaker, what you can say about beaker is it is made of glass. Glass is an insulator. So that means you're not thinking. If glass is an insulator instead of metal, whatever you heat up, not all the heat is going to get into the water if you use glass, because glass will not conduct heat very well. If you heat 100 kilojoule here, not all the 100 kilojoule will go in here because the glass is an insulator. So you don't want to use beaker, which is made of glass. Okay, the metal can is good because metal conducts heat. You can ensure as much energy from here goes into here. If this apparatus is using beaker, you can improve the accuracy by changing beaker to metal. Because if you use insulator, you don't get 100% conservation of energy. Glass is insulator. It will not allow all the energy from here to heat up the water. Now we are heating up water. Okay, so which means if you lower this distance, if you make this gap smaller, meaning to say you move the burner closer to the metal can, here you are heating up air, not air in layer, but air. So air is an insulator. You know about air being insulator. Insulator is bad because they don't allow your heat to conduct. 100% conservation energy is an assumption. If you can close the gap, you can reduce the heat loss to the air, the surrounding. You want to ensure all the energy from here goes into here. Okay. Another thing you can do is close the lid. Use a plastic lid. Now, why do we want to use plastic lid? Because the plastic is an insulator. Insulator will prevent heat loss. Why do we use a lid? So that the heat doesn't escape to the outside. If the heat escapes, we don't get 100% conservation energy. The more heat is lost here, the lesser is the conservation energy, the less accurate is your result for your TF minus TI. The lower the gap or the bigger the gap, there's more air in between. You're going to get more insulation. You're going to have less accurate transfer of energy into the water. That is the loss of energy from here. Now, another thing you can talk about is you can cover this up. So people can say you can insulate this space here so that you don't get heat loss to the surrounding. The more heat loss you have to the surrounding, the more energy is not conserved, the less of the energy goes into heating the water, the less accurate is the final temperature, and therefore the less accurate is delta T. Therefore, the less accurate is the enthalpy change that you work out from there. So just to summarize, this is an experiment which is exothermic. Combustion is exothermic. The error in this experiment comes from heat loss. If you can minimize heat loss, you can improve accuracy. So how do you minimize heat loss? Use a lid, use a plastic lid, use a metal can instead of beaker, insulate the burner so that you don't lose the heat to the air, to the surrounding. You can reduce the gap between the burner and the metal can so that we are not heating up the air in between. We are not losing more heat unnecessarily to the surrounding air. Okay, hopefully that makes sense there. Are there any other question in this work that you want me to go through? Okay, I guess that is okay then. So have a look through it. If there's anything you want me to go through, then let me know, okay? This is energetics work 4. Have I gone through work 4 with you guys yet? Probably not, right? Okay. Actually, let me just go through my work 4. My work 4 is probably better. So this is probably the last corrections we'll go through. This is another alternative to practical paper. Alternative to practical is more likely, especially when practical might not be a choice anymore this year or next year, depending on how COVID is. So, reading the thermometer, again, this thermometer is whatever is given to us. We need to be able to read it correctly. By right, I should read it to 0.0 or 0.5. So you can write 91.0, 73.0, 65.0, 54.0. I'm pretty sure when I mark this work, quite a few of you actually mess up reading thermometer again, okay? And this is just about the volume of water. We keep it one decimal place because we follow the accuracy in the questions, in the options given the question previously. So like that, you get the 3 marks, shouldn't lose easy marks like that. People in general are okay with plotting graph, but I just want to remind people again, do not put in data with a cross if you don't have the data. This is the next part. I do not put in the crosses because they are not actual data. They are 1, 2, 3, and 4 data because they were 1, 2, 3, and 4 data. So there should be 4 crosses only. If you are asked to use the graph to get a value, you read and you show construction line, but do not put extra crosses. Okay, hopefully that makes sense to you. And make sure use pencil. Do not use pen to show your graph. Yeah, you know that. Yeah, do not use pen for diagrams or graph. Do not use pen. Use pencil. Show clearly on the grid. For 3 marks like these, you must be able to show clearly on the grid when the total volume of water in the solution was 20.0. So first of all, you get 1 mark for extrapolating. Extrapolate means follow the trend. Now, some of you, you just decide the value. When you decide the value, your graph looks weird. Like I know some people, I saw one person, if I'm not mistaken, that person decided the value is here. Then suddenly the graph looks really nice. And then suddenly the graph looks like this, like that. So it looks weird because this person decided suddenly it has to be there. You don't decide this thing like that. You follow the trend of the graph because it's a curve and not a straight line. We can see the curve will go downward. So anyway, somewhere there, like 50.0 or 52 should be okay. If it goes upward, it doesn't follow the trend. So it's not okay. Now here is also, I can extrapolate and go upward like that. So hopefully that makes sense. People in general are okay here. One answer is not okay. People say when you see colorless solution, well, not every salt is going to be colorless, right? Because transition metal salt is going to be colored solution. That was from your year 9 qualitative analysis. What does it mean when you have a colored solution? That means it contains transition metal. It's not transition metal, it contains transition metal ions in solution. So be very careful when you say colorless, when you don't even know the identity of the solid. Okay, so just be careful there. I'll come back to this in a little bit. Sketch on the graph, okay. So if salt C is less soluble in water, this goes back to your year 9 on crystallization. Crystallization is used to get soluble salt. You get crystals from the soluble salt because you can't filter them. You cannot tapis because it's not like insoluble and soluble. It's soluble in the solution. It's soluble in the solvent. So to get soluble salt, you have to do crystallization. So the crystals that first appear will be less soluble. You heat until it's saturated. Saturated was your end of year exam question. It means the maximum amount of solute that dissolve in a solvent at a particular temperature, because temperature can change solubility. Temperature can change when your crystal first appear. The less soluble you are, the more you want to come out as crystal. Okay, you come out as crystal because you are less soluble. You crystallize out because you are less soluble. So this one is about less soluble, less soluble. So if you are less soluble, that means hang on, what am I talking about? You are less soluble. So if you are less soluble, actually, what am I talking about? Let me try and max out this graph. Blah, blah, blah. If you are less soluble, therefore you will crash out first. If you crash out first, I'll come back to this in a little bit, okay? I'll probably have to explain to you another time. Let's just go on with this first, okay? This is an improvement to get reliable results. I think I can apologize for not going through this beforehand, but you should really, try and understand the difference between reliable, a fair test, and an accurate test. To get a reliable result, it's not about accuracy. It's about repeating it for consistency. In your titrations, you repeat the titration to be consistent, and then you average them to get reliable result. Consistency, meaning to say the readings should be consistent to each other, and then you average them to be more reliable. Accuracy is to do with the use of better equipment, like instead of this thermometer, you can use a thermometer like we did for work 5. There was a much more accurate thermometer. Instead of, so you use a burette here. I forgot the earlier bit of the question, whether you use burette for both of them or not, blah, blah, blah. So you use burette for distilled water. You use burette for the solution as well, I think. No, there's just all distilled water. So you already use burette. That's as accurate as you could get really already. So I could simply improve the thermometer. Using a more accurate thermometer, that could result in a more accurate experiment. I could try and reduce heat loss so that I'm doing a solubility experiment. Preventing heat loss will keep the temperature to be whatever I set it to be. In this next part, I don't know, people started writing equations. This is about experimental procedures. It's not about theory. It's more about the practical steps, the practical procedures. So make sure you know the difference between theory and practical. You mix the solid, but you need water. If you don't have the water, you don't have solutions. You don't really measure temperature of solid. It's difficult to measure temperature of solid, right? So what you do is you measure temperature of solution. Ideally, you want the solution first, measure initial temperature using a thermometer, put in the other solid, measure the temperature, well, the final temperature. If it is endothermic, the final temperature would be lower than the initial temperature because endothermic reaction absorb heat energy from the surroundings and your solution will get colder. And that was what you saw in the lab for an endothermic reaction. And you saw an increase in temperature last time for an exothermic reaction. Unfortunately, if you are absent, you just have to catch up with the experimental tutorial videos where I actually show you the temperature reading for some exothermic and some endothermic reactions there. This last one was very, very badly done. Okay, you need to be careful. The test for ammonia versus the test for ammonium. I've highlighted these back in year 9, and I'm going to highlight this again. There are 2 pages. There are 2 pages for the test of cations, anions, gases, and phlegm test of cations. Okay, we are just reviewing year 9 syllabus last lesson actually, and the lessons next week as well. It will not be enough to make you suddenly become, very knowledgeable unless you work on what are your weaknesses and you work until those weaknesses have been patched, have been covered entirely, so that you will never ever fall back ever again. You have to add some sodium hydroxide. This is the theory behind it. I hope you remember. They are not asking for the ionic equations, any hydroxide plus any ammonium salt. This was straight from year 9 qualitative analysis, end of year examination corrections, as well as something that will come out again and again. The NH4 plus donates the H plus. It is acting as an acid. The OH minus is acting as a base because it accepts the H plus. In doing so, it kicks out the ammonia. As you lose the H plus, it becomes ammonia. As you accept the H plus plus OH minus give you water. We don't call this neutralization because ammonia is basic. Ammonia can dissolve in water. We don't really get a neutral solution. We don't call this neutralization. We call this displacement reaction, displacement of ammonia. This is one way of forming ammonia in the school laboratory. It excuse me, it is this gas that you are testing with the red litmus paper, and people say NH3 is present, but the question asks for ammonium ions. If you simply test for NH3, but you don't get NH3 without the aqueous and the OH, without the heating. Okay, hopefully that makes sense there. All right, I think I'm just going to stop for today. So screen time is a bit too long already. And whatever you are lacking in understanding, you can always just text me to ask me directly, or just to watch the work solutions, the work tutorials that are available online already. You can just skip to the sections that I haven't explained very well, that you still don't understand, and then you can just text me if you don't understand any further. Okay, so I'll see you guys in the lesson next week. And before you go, let me just very quickly take attendance, because there are some people who cannot what am I going to say? Who cannot see this, who cannot hear me, or who cannot say anything on their mic. So I'm not sure what they're doing, training Zoom or whatever. Okay, thank you everyone. Free to leave. Make sure you correct your work and you do corrections on it, and I'll see you guys next week. Thank you.
Thank you, sir.
Thank you.